Imagine your data, AI data to be exact. Data comprised of billions of pulses of light that travel over and across the internet, carrying information derived from intelligence that is critical to your business. If your business relies on real-time data delivery arriving at a second's notice without quick crash or system failure, Super Micro is the clear choice, delivering extreme performance with petascale all-flash NVMe storage to support proven architectures for AI and ML workloads, with leading software-defined storage platforms. If you're an enterprise business, government agency, or in the education and research sector building a public cloud, private cloud, or generative AI supercluster, there's only one choice. And that choice can only be exactly the best.
Hello, and welcome to this session of the Supermicro Open Storage Summit about how CXL enables new use cases for storage and servers. I'm Rob Strechay, Managing Director with theCUBE Research and your moderator for this special session. CXL memory, or Computer Express Link memory, is a unified interface standard designed to address bandwidth limitations in data centers. It was first outlined by the CXL Consortium back in 2019 and aims to connect various computer chips and memory devices through a PCIe interface at low latencies and faster speeds than traditional methods. The importance of CXL memory lies in its ability to enhance data throughput, reduce latency, and improve expandability of data center infrastructures. As technology advances, like generative AI, autonomous driving, and in-memory databases continue to grow, data center operators face increased demands for higher memory bandwidth and scalable solutions. Moreover, CXL helps existing data centers upgrade their performance without incurring significant costs. For instance, it allows for better resource sharing between CPUs, accelerators, by maintaining memory coherency, which simplifies the software stack, complexity, and reduces overall system costs. CXL memory is crucial for modernizing data centers to handle the growing demands of advanced technologies efficiently while keeping costs manageable. Now that we've kind of laid the groundwork for that, we're going to jump into a discussion. And all the materials that you're about to see from our partners, just so you know, will be available on the session link where you registered on thecube.net. The speakers will also be live on X to take your questions. For that, use the hashtag SuperMicroStorage 2024. Now let me introduce our speakers. Andrey Kudryavtsev is the Senior Manager of CXL Business Development Micron. Anil Godbole, who's Xeon CXL Strategy and Marketing Manager at Intel. Steve Scargall, who's the Senior Product Manager and Software Architect at MemVerge, and Puneet Anand, who's the Senior Product Manager, Storage Systems at Supermicro. Really happy to have you all here. I think this is really exciting. CXL's been around, as I just said, since 2019, and again, we have the people who've been really working in the guts of it since then, but really looking at how it probably makes more sense than ever for CXL to be a topic of discussion, especially with this. So, Anil, let's kind of start off with you. And as we all know, Intel really was the inventor of CXL concept and significantly contributed to and formed the CXL Consortium back in 2019. Intel's involvement in CXL is not just about technical contributions, it's about shaping the future of high-performance computing by enabling efficient and scalable interconnects between processors, accelerators, and memory. By leading the CXL initiative, Intel is driving innovation and accelerating the development of next-generation computing architectures. From the processor and compute point, can you shed some light on the benefits of memory hierarchy?
Thanks for the kind introduction to Intel and also to CXL. You rattled off all the right features of CXL, almost stole my thunder. But
sorry
CXL,
about that.
but CXL, as you said, right, is from the get-go is meant as a cache and memory coherent link between the processor and the device, right? So it runs on the same rails or the PHYs as the PCI links. So that means we didn't have to invent new I/O types. That's the big first benefit. You simply run CXL as an alternate protocol over the existing PCI links of the processor, right? But CXL will allow or will lend itself to having lower latency and therefore higher performance compared to PCIe. And the reason being is not because the electrons fly any faster in CXL, but it's because the CXL accesses are memory cacheable, meaning when a link end, let's say a processor accesses the device's memory, that memory is like an extension of the processor's DRAM, and that means it's cacheable. On the other hand, if you access the same memory through PCIe, right, it's not cacheable, so you have to read it one by one versus rather than getting the whole cache. So there itself is a big latency benefit. Okay, that's point number one. And CXL was invented both for heterogeneous computing as well as simply adding more memory, because the device memory is now part of the processor address space. Now that latter use case has really taken on, and the big reason being, as the processor core counts have gone up over the years, right, there's only so much DRAM one can provision, right? And yes, CPU makers are doing their best to add, they continue to add memory channels, but memory channel is so far wider compared to what a CXL link can provide. So that's one, right? But they do their best, and at some point, there's only so much memory can provision. So the big use case emerging is the addition of more memory to the system, right? So the big workloads, big meaning big memory footprint workloads like the databases are the first ones come to mind, which will benefit right away. And now, because there are more ways to access memory, the memory bandwidth also goes up. And so there are other applications like AI, HPC, who also want bandwidth in addition to capacity. So they benefit, right? So this is the main use case. Now there's another use case, not use case, but a big benefit is the TCO. As you know, Super Micro knows, today memory DIMMs are the single highest, priciest component in the bill of materials of the server. Right? CXL modules, on the other hand, can use memory from previous generation, like DDR4. So that's one way to save the cost of memory. And secondly, a new use case is emerging, which is the memory pooling, which will allow CSPs or cloud service providers to provision their motherboards with only minimal memory. This way, they don't have to over provision. If there are like 100,000 server boards in their data center, do the math, right? So now they can get away by provisioning almost 25% less memory, and use any workload needs more memory can go to the memory pool, and which is attached via CXL, and that's how you save money as well. So
no,
that's a big promise.
I mean, that to me is, I mean, like you said, from databases to data lakes and all of that, with all the metadata that needs to be kept that way, it totally makes sense where this would be great piece for them to really understand that as well. So, Andrey, I think the next question was for you around this, and the contributions that Micron is making are significant. The CXL memory modules and active participation in the CXL consortium are driving the adoption of this transformative technology in the industry data centers. Their focus on innovation and collaboration is helping to shape the future of memory and interconnected solutions for high-performance computing. Let's start with understanding Micron and what's going on. So, Andrey, in the context of AI, can you talk a little bit about the challenges affecting the memory subsystem and how CXL will address, or how it addresses, this gap?
Of course, and what I'm saying is not only applicable to AI, it's applicable to all generic compute. And I first want to second to Anil's perspective on the overall CXL as the new infrastructure. It has so many different applications, and memory application is just one of these. And being on a memory company, of course, I want to give you a memory perspective why CXL makes so much sense these days, especially at this time where we have so much demand for the resources. For applications like AI is one good example, but there are others like HPC, like databases, again, another example that Anil brought. So the idea of having easily expandable memory in the system is actually helping us to overcome the challenges and limitations of overall platform design. And platform always limited by the physical form factors of the memory modules that you can plug in the server, on the total quantity and capacity and density of those that you can have a total capacity. So CXL allows you to expand that memory capacity easily, so you can integrate additional memory over a new interface called CXL, and given the relatively similar performance of memory, so the performance of a single CXL device, like in the case of a Micron product, CZ120 that we introduced recently, is similar to the performance of a single DDR5 channel. So you add additional CXL memory module, it's like you added, in terms of a bandwidth, additional DDR5 channel to the system. Latency has some differences, and that's what allows us really to talk about memory tiering configurations within the platform. And that's what's been people talking for many years, and the problem that's called memory wall is actually the situation where your performance of your compute engine, let's take in that case your CPU cores, is growing, and the number of these cores is growing much faster pace than your overall memory capacity. So the ratio of a memory per core is actually declining because you have so many cores in the platform now, and you have to keep up with the memory. So adding extra memory to the CXL interface allows you to overcome these limitations and continue growing. It's like the next step that platform can make.
Yeah, I love that, breaking down the memory wall. Yeah, I mean, that to me makes total sense in what folks are really looking to need to get to, especially with these newfangled AI applications and data lakes and databases, but even traditional transaction systems and things of that nature that need big memory. But let's kind of switch a little bit up, and Puneet, in the industry, Supermicro and Intel are almost synonymous with each other, and your partnership is as old as Supermicro itself, for that matter. As a leader in server technology and platforms, you've always been first off the block when integrating the latest technology and taking it to the market. You're in a unique position, I would say, where you get to work with multiple vendors and partners to deliver new products and solutions to solve real business problems. And the presence of both Micron and Intel is a testament to that here. So I got a two-part question for you. What do you see as the limitations of current platforms in addressing the trends that Anil and Andrey have mentioned? And second, please share solutions and products that Supermicro is envisioning or putting out or working on to address these real problems.
Thank you, Rob. Thanks, Anil and Andrey. These guys gave a very good introduction to CXL, but components wouldn't be helpful if they weren't put into a product or a platform, and that's where Supermicro comes in. Let me go a little bit back. I've been in industry for a long time, storage industry. However, Supermicro, I joined them recently, and we are known for speed of execution is what Supermicro is famous for. But one thing that I've also seen here is also the foresightedness that the leaders have had. Way back when in 2017, EDSFF format was just coming up, we were already there ready with a product. Our first EDSFF petascale product actually came out in 2017. So, and when the OCP guys came up with DCMHS and other standards, we were right there. So we weren't going to be left behind when CXL came up on, right? So very tightly working with Micron and Intel is what you're seeing on your screens, this platform that I'm going to talk about. This platform is based on our petascale, new platform based on petascale Xeon 6. It has a twin Xeon 6 Intel processors. As you know, the CPU has 8 memory channels, and since there's dual memory, dual CPUs, we have 32 channels, right, on this one. Enough memory. Also, one of the other things that is great about this product is the balanced PCI channels between the front I/O and the back. This product has 32 EDSFF drives and also enough I/O in the back for all the networking and other needs that you might have. So what we did is we used this platform to introduce the Micron CXL memory that Andrey talked about. It's a 2T thick memory, EDSFF format, and you can put 8 of those in this box. A 256 gig memory that Andrey talked about, you're going to have 2 terabytes of CXL memory, apart from what you already have on the host for all the DIMMs that you're going to put on your host memory. The other greatness about this product is it's a unified chassis, balanced architecture I already talked about. If you look at this picture in the bottom left, you will see that the EDSFF has a better airflow than the U.2 traditional that we are used to. Anyways, that's about the platform. We are very excited to have this product out there. I'm going to touch on a couple of things, a couple of more things. The main one is one of the challenges that I think the gentleman talked about. Andrey touched on this a little bit. As some of you guys know, that when you have dual memory channels, you can get capacity. Even though you can add more memory to the same channel, after you fill up all the banks initially, you're going to run into performance problem, and that actually causes performance all across all the additional capacity that you've installed. That's where CXL comes in my opinion. You do not need to go dual channel. You can just install 1 DPC per channel, get the performance, and then get additional CXL memory for the performance that you really deserve for, Anil talked about memory-intensive applications like SAP HANA and some of the other ones. Anyway, great product, CXL ready to ship whenever somebody's ready.
Thanks, Puneet. I agree totally with that, and that looking at the different channels and how to give people more memory and more memory access, especially with everything that's going on in all of these applications, to me, it seems like the right technology at the right time. But let's kind of, focus back on with Andrey and Anil. Products need to be solutions for them to bring business value. Also, the concept of tiered memory isn't a new thing. In the end, the role of Intel, Micron, and Super Micro is to solve customer problems. My next question is the same for both Anil and Andrey in that context. What workloads or business use cases will benefit from this new type of memory? Let's start with you, Andrey.
Yeah, no problem at all. Well, first I would like to mention really second what Puneet said about this system. This system has unique capabilities. It can be used in so many different ways. It can be expanded for memory. In addition to big memory capacity, it could have significant storage capacity, external I/O capacity, and so really can cover many use cases. I'm going to just cover 2 use cases that we've been working all together recently, and both of them related to the AI workloads. But I don't want to limit this system only to be AI machine. It's a great AI machine, but it can do way more than just only for AI workloads. So I understand that's also quite unusual for many server customers to see memory goes to the front slots. And that's what E3.S is, right? So it goes to the front slot. You get extra memory capacity in front of the system. And that gives you also serviceability of that memory that you can use with the software. When you enable software hot plug for extra memory capacity, it can be leveraged really there. So in one of these stories where we created together, we used extra CXL memory capacity on the Super Micro system with a MemVerge memory machine for the accelerating GPU AI workloads. What it does give us? It gives us very large capacity of a memory tier where we can prefetch the data and go into the memory domain instead of loading from the storage. Why it's important? Well, no matter how your storage fast, and your application always has to do the translation to the block layer, and always has to, translate your request for the data from the memory semantic into the block semantics and back and forth. When you integrate it all together in a large memory pool, what you can do now, your GPU can naturally fetch the data from the large memory capacity and do that on a much faster pace. And because it's doing it much faster with way less lags or latency or interruptions, your GPU load can be improved. And that's exactly what we're showing here on the slide. So when you look at the 2 comparisons, one is just with a regular workload running on the top-end NVMe SSDs, you see that GPU performance starts really at 100% and then fluctuates over time. And this is happening because the data is being fetched from the NVMe SSD. On the opposite situation, when you preload that into the memory domain, your GPU has a constant load, and by having it fully utilized, you finish your workload faster. And in case of AI, like a batch processing, that's what matters really. You can deliver your time to result much faster. Your GPU utilization is much higher, so you have a higher TCO of overall system utilization, and that's really important. So that's for GPU case. The other case in AI that we've been really working closely with Anil and Intel team is how we can improve the performance of inferencing using CPU inferencing. And with the latest Intel advancements, like on the Xeon 6, with the latest AI technology built into the CPU stack and additional features for acceleration, we can combine CXL memory also into the same configuration to expand total memory bandwidth and capacity all together at the same time. So that gives us additional speed improvement for the workloads that running on a host CPU. And that's also a really great story, how customers can improve utilization, how you can get more users serviced at the same time, or how you can reduce your wall time of a workload.
Anil, anything to add to that?
Well, I think he already pointed out, but let me just reiterate a few things. So first one, again, the big use, as I pointed out earlier, is the increased memory capacity. And we all know, right, even good old days, we'll say, hey, just add memory, right, make the system go faster. That very much holds. And today, we have all these virtualized infrastructure. More the memory, more VMs can be serviced, especially when the processor core count is really high. So that's, I would say, immediate beneficiary. He already, Andrey mentioned about the AI, ML work cases. We talked about the in-memory databases, right? There's so many others, like HPC, they always, they are really crunching really big data, like database problems, right? Like weather analysis or whatever. And then there are others, like you go into the media, right? So content delivery networks, they are always buffering all kinds of websites and data needed by the various users. We have the pharma people who are doing genomics. I mean, you name it. I mean, there's so many applications, just want more memory capacity. And the second one, as I said, by doing a technique called address interleaving along with CXL memory, one can increase the bandwidth of the system memory. Now, the number one workload which benefits, I think Andrey already mentioned, is the AI ML workloads, right? They want not only capacity, but also want the bandwidth, HPC is another, and the non-relational databases is another use case of higher bandwidth. And not to be forgotten, last but not least, is a lower TCO, reduction of TCO, which CXL can offer, right? And again, it can do it two ways. Behind the CXL memory buffer, one can use lower generation memory like DDR4, which is cheaper. Rather than using the same equivalent capacity DDR5 DIMM, one can get away with using a DDR4 memory. And using these things called memory pool, which are just a bunch of memory or J-bomb boxes within the rack. And data centers, CSPs can now provision their individual motherboards with much less memory and go to the pool only on demand if some workload wants it. Otherwise, most workloads are happy with a normal memory. They don't need to over-provision. So these are definitely the big benefits, the immediate benefits of CXL.
Yeah, I mean, it totally is what people are looking to, especially lowering their TCO, especially when you're looking at how they're stealing budget to do AI, ML in most cases. Being able to bring that together at a lower TCO is huge for them. But let's turn to Steve here for a second. And of course, you will need software to utilize the CXL technology. MemVerge's overall contributions to CXL are significant and been at the forefront of developing software that leverages the power of CXL to create a new generation of memory-centric computing solutions. I hear your work is helping to accelerate the adoption of CXL and unlock new possibilities for data-intensive applications in areas like we're talking about of AI, ML, big data analytics, and high-performance computing. I have a two-part question for you as well. And why don't you tell us more about the challenges required in the operating system, or the changes required in an operating system and hypervisor to fully utilize CXL's capabilities, and using CXL, what new possibilities does it open up for managing large-scale data storage as well?
Thank you, Rob. Great question as well. We work closely with all the partners here, and of course, the operating system is the first level of software that needs to run on top of the platforms, right? So the great news there is that in the past 1 or 2 years, Linux has been working very closely on CXL enablement. So if your operating system is available, or has been used in the past 1 or 2 years, then it'll have CXL support. If you're using a slightly older operating system, for example, then there are features in the platform itself, in the BIOS, that allow you to have the platform manage CXL memory. So the operating system doesn't necessarily have to be CXL aware at that point. Now, leveraging on the newer operating systems, CXL gets exposed as NUMA nodes. The applications, if they're NUMA aware, can use that directly. If not, then our own MemVerge memory machine has the capability of transparently tiering memory on behalf of unmodified applications. So there are a whole pile of applications out there that have no concept of CXL and different types of memory available to them in the same box. So that's where our technology comes in and manages that for those applications. Now, for those more adventurous developers out there that want to get a little bit closer to the hardware and truly accelerate their applications, then they're able to do so using standard operating system calls like memory maps and true byte addressable operations like Andrey was saying earlier, right? You're no longer encumbered by block access and all that read-write overhead. So that's where we are today. And then as we move towards the future, Anil and Andrey were talking about some of this earlier, right? As we start to get different devices with different features and capabilities, the operating system is already leading that development there. So there are already capabilities in current kernels that support this ahead of the hardware, that allow us as pre-development environments to take full advantage of that and adapt our software so that when hardware is available, it's ready to go from day one, right? So that's what we're showing on my slide here, is that the transition from where we are today and where we're going in the future here for both Linux and the applications. So.
Yeah, I mean, that is great, because I think, again, it extends that TCO story where you're talking about applications that may have been written 10, 15 years ago and have no concept of this, and maybe on hardware that's not ready yet, and how do they transition to that and use these techniques? I think, Puneet, question for you. So if organizations watching want to get their feet wet with CXL, what's the next step? Where should they go, and who should they be talking to?
They should be talking to Supermicro. Jokes apart, go to supermicro.com, search for CXL. You should be able to find the platform I just talked about, and we'll get back to you. This platform is ready to ship. Again, dual Xeon 6, dual processor, 8 CXL memory devices. This is the first platform out there which can do this.
Yeah, I think to me, it makes a lot of sense. People are going to want to start to go down this path, especially with all of the things that you've laid out around AI and ML, and as people build these applications that contain different pieces from data lakes, databases, in-memory databases, and AI, ML, and generative AI as part of the same data products. This is totally where people want to go. So kind of to the group, how long will it take to get to this future of memory pools and CXL? Let's start with Andrey, and then we'll kind of go around the horn this way.
Future is now, so don't wait. Systems available. You see how big that trip that CXL already made in order to get to the market. To me, it reminds like when over 10 years ago, the first NVMe SSDs came to the market and really disrupted the storage market completely and moved away from the SATA SSDs. The same is happening today, how we can expand the memory market and what innovation we can do on the device level, on the platform level, and on the software configuration. And you see that here around four of us, there is so much interaction happening. This didn't happen for many years, and you see the unique combination of companies working together for the whole industry to get it enabled.
Anil?
Yes, so we also believe Intel is fully committed to the CXL on their processors, but people have to keep one thing in mind, right? The CXL, there's so much interest in the CXL consortium. There are 250 plus member companies. The spec has gone from version 1 to version 3.1 now in a small span of 4 years, right? Just to remind you, PCI took more than 8 years to do that kind of thing. There's so much interest. However, but because of that, the CPU manufacturers like us can only keep pace. Just because the spec has already gone there, we cannot just put out a CPU to address the latest spec features, right? So that will limit the adoption in the near term in the sense for the latest features. But CPU is now already at version 2 of CXL spec, which added the memory pooling feature. Besides adding the memory, we waxed eloquent about the benefits of adding memory at the node level. But now with the memory pooling, as I said, CSPs are embracing that as we speak. And I feel in the near term, it's looking very good. So.
Puneet?
Well, Andrey stole my NVMe example, but I have another one. I mean, 2010, 11, there were a lot of naysayers on EV, and Tesla was kind of like the leader. But look where we are today, where all the auto guys are behind them. I kind of feel very similar about CXL. You saw the platform. This is ready to go. Test it out, and I think the future is really bright.
And Steve, I mean, you guys are pushing in on this and trying to accelerate it. So what do you see? Yeah,
I mean, fantastic. So, echo what the guys have said here, right? I mean, the future is now. Our software is ready to go for the devices that are available today. We've got emulation of future devices. So again, we're able to use that technology to further our software development so that, again, we're ready for when that hardware lands. And, I'm super excited for what pooling and definitely what sharing can do for us in the very near future here. So.
Yeah, I think that to me I like the whole message of the future is now, because I think when you start to look at what people are trying to do in these data centers, especially about sustainability and other aspects that this will help as well, beyond just the TCO aspects. But I think to the Tesla, hey, EVs, 10 years ago, there was like Prius, and that was about it. And you start to look now, and everybody's got a whole fleet of them. It seems like this has got that momentum now to really, push in and be that. So I want to thank you all for being on here. This has been fantastic. I've learned a lot. Hopefully those who are watching have learned a lot as well.
Thank you, Rob.
Thank you. Thank you.
Also note that all the Supermicro sessions, in case you may have missed one, will be available on the on-demand link that where you registered for on thecube.net. Thank you for watching this episode of how CXL enables new use cases for storage and servers. And go to that site and see all the ones you may have missed. There's some great stuff up there.